Hi, this is Jack from Maths Forge, and in today's lesson we're going to be doing volumes of pyramids and cones. So let's take a look at our first example. Here we're being asked to find the volume to one decimal place of this square-based pyramid here. So the formula for a pyramid volume is going to be the base area, so this area of the base of the shape here, the square, times the height, which is this 14.6, and then all of that divided by 3. So let's go ahead and see what this looks like when we calculate it. So for the volume, we're going to have the area of the base. This is just a square, so I'm going to do 15.7 times 15.7, and this gives us the area of the base. And then we're going to multiply this by the height of this pyramid, which in this case is 14.6. And then we're going to divide everything by 3. And putting this into our calculators, we get the following: 1199.6 to one decimal place. And don't forget, since we're finding the volume, it's going to be the units cubed. And in this case, the units are meters. You can check from the sides. So the units are going to be meters cubed. And if we check our answer, there it is. So now let's do a 2-star example. Here they're asking us to find the volume to one decimal place of this cone. They've given us a radius of 15 meters and a height of 10 meters. Now the formula for the volume of a cone is the base area times the height divided by 3. So similar to a pyramid. For a cone, the base area is a circle. So the base area for a cone is pi r squared. So now if we calculate this, the base area is pi r squared, and in this case r is 15, so it's going to be pi times 15 squared, times the height of this cone, which is 10, all divided by 3. Putting this into our calculators, we get the following: 2356.2 to one decimal place. And since we're calculating a volume, the units are going to be meters cubed. And if we check our answer, there it is. Now let's do a 3-star example. Here they're asking us to find the radius to the nearest whole number. They've given us a height of 15, they've labeled the radius as an x, and they've given us the volume of this cone, which is 4021.2 meters cubed. So let's go ahead and use the formula for the volume of a cone and replace the cone volume by the actual value that they've given us, which is 4021.2. This is now equal to the base area of this cone, and don't forget that the base area of a cone is a circle, and the area of a circle is pi r squared. Now you can replace r with x if you'd like, or you could just leave it as r, but the radius is what we're looking for. And then this is going to be multiplied by the height, which is 15 in this case, and this is all divided by 3. So now to find the radius, it's just a matter of rearranging for r. The first thing we're going to do is get rid of this divided by 3. And we're going to do this by multiplying both sides by 3. This now gives us 12,063.6 on the left-hand side. And on the right-hand side, it gives us pi r squared times 15. Since the divided by 3 and times by 3 has cancelled out. The next step is to get rid of this times 15. So we're trying to isolate this r. So I'm going to get rid of this times 15. And I'm going to do this by dividing both sides by 15. This leaves us with 804.24 on the left-hand side. And on the right-hand side, it leaves us with pi r squared. The next thing I'm going to detach from the r squared is this pi, and it's attached to it via multiplication. So I'm going to detach it via division. So I'm going to divide pi to both sides of this equation. This now leaves us with the following: 804.24 over pi. I'm not actually going to do the calculation for this step straight away. I'm just going to leave it as it is. And the reason for this is because if you do the calculation straight away, you might end up with a very long decimal number. And if you cut any of the numbers out, you're going to sacrifice your accuracy at the end. So it's better to just leave this as it is and do the calculation at the very end. But this now leaves us with r squared on the right-hand side. Now, the only thing left to do to get r on its own is to get rid of the square. The opposite of squaring is square rooting. So I'm going to go ahead and square root both sides of this equation. This is now going to leave us with the following, which I'm going to write over here. R on the right-hand side, and on the left-hand side, it's going to be the square root of 804.24 over pi. Putting this into our calculators and calculating it, we get the following: 15.9999. But they do want the answer to the nearest whole number, so we're going to give them 16. And don't forget the unit. Since we're calculating the radius and the radius is a side, then it's going to be meters. And if we check our answer, there it is. And that's it for the lesson on volumes of pyramids and cones.